Welcome everybody. I'm very pleased to welcome you to this Raspberry Pi Computing Education Research Seminar. I'm Sue Sentence and I'll be chairing this session, and in a moment I'll be introducing Pratim Sengupta, who's our speaker today, all the way from Calgary and Canada. This is our second seminar in the series on cross-disciplinary computing, and this series is running all the way through till November. And in this series, we're exploring interactions of computing with various aspects of learning and considering what computing education looks like in different contexts. As usual, our format is 35 to 40 minutes presentation. Then we split into breakout rooms so that everybody has a chance to chat to somebody else and share their perspectives. And then we come back together for a whole group Q&A, an opportunity to add our comments and our questions for Pratim. And I'm delighted to introduce Pratim to give his presentation today. Pratim is a professor of learning sciences and STEM education at the University of Calgary. And the title is rather challenging for me to pronounce. So his title, he's talking today about computational heterogeneity in STEM education. I'm being recorded and I hope I got that right. He's conducted studies in science classrooms and non-formal spaces and focuses on providing open and engaging experiences for anyone to explore code. We're really looking forward to listening to you today, Pratim, and hopefully you'll share some of the things that you've written about in your new book. And over to you if you want to start presenting your slides. Thank you.
Thank you so much, Sue, and thanks everyone for being here. Thank you so much. All right, so the title has already been mentioned. It's Computational Heterogeneity in STEM Education. So I'm going to start with a brief orientation, and then hopefully the point I want to communicate will unfold in three parts. So the fundamental anchor of the work here is code and coding are languages, and not necessarily the kind of what Herbert Simon would call artificial languages. Code, when it lives on the screen or on a device or inside a device or in the form of wires and cables, that is one existence of code. But the moment human beings start interacting with it, it is no longer just a symbolic language. It is a fundamentally interpretive experience. It also means, and Bakhtin, and a lot of this work is actually based on the scholarship of Mikhail Bakhtin, who's a scholar of language and literature. And Bakhtin was really standing up against Russian authoritarianism, and very prescient to this day, actually. And he argued that, and the way he fought authoritarianism was through showing that language is fundamentally seeking others and other worlds and othernesses and other meanings. So, and perhaps the most beautiful phrasing of his that resonates with me is this idea that a word is never owned by anyone. It's always half ours and it's half owned by others. And in history, the word is as much as it exists, as much in its future unfoldings as it is in its different histories of the same word, right? Even the word code, for example, we could look at the history of the term, and we will be just fascinated by the different ways in which code has been present in our lives across centuries, across different civilizations, and even before. And so the point I wanted to make is, and I still want to make through this talk and beyond, perhaps through the rest of my life, is going to be that attending to heterogeneity can counter technocentrism. We'll get into these words in more detail. And I'm going to share a story in three parts. So I'm not going to be able to go into very deep in any one empirical work, but I'm going to share key insights from a whole bunch of empirical works that we have done. I've done with my colleagues and my students. And the stories are going to unfold in three different realms, three related but quite distinct realms. One is going to be pedagogy in classrooms. One is going to be discipline. It's almost like those mathematical transformations that preserve mathematical identity. Discipline is what gets preserved. Even as we move across different settings, what gets conserved. In a Piagetian sense, it's the ideas that remain invariant across transformations. And then what is the core what are some of the cores, the invariant cores that we have kind of taken for granted in computing, and how might they need to change? And then the third part is going to be public imaginations of code. So I'm going to start with technocentrism, and for those of you who've had the chance to read the first chapter of Voice in Code, by the way, the entire book, thanks to my wonderful editor, Susan Buckley at MIT Press, it's open access. And this is all her doing. This is a true gift for me, at least. So you can go on the MIT Press website and search for Voice in Code in STEM, and it'll give you two options, one that you can pay for and one that you don't have to pay for. And so click on the one that you don't have to pay for, and it'll take you to the open access website. And you can download each chapter individually. And chapter 1 is entirely dedicated to technocentrism and how, where it shows up. And I've tried to be as colloquial with my co-authors, Amy Ferris and Amanda Dickus, throughout the book. So technocentrism is basically, I'm borrowing this term from Daniela Rossner, device-centered, the wonderful book that she wrote. I encourage everybody to look up Daniela Rossner's work, Morgan Ames's work. Morgan Ames has been a foundational scholar for my own thinking over the last few years, and really highlights what happens when we just center devices and code, rather than the more complex and uncertain and ambiguous and the fundamentally ambiguous nature of human experiences. And when we do this, we ignore teaching, we ignore social and institutional infrastructures, we ignore cultural histories. Now, given that most of the world is not white, most of the world have experienced generations of colonization, this becomes really important, and we cannot separate our pedagogies, we cannot separate the devices that we manufacture from these histories. So this then, the other brings us to the next important tenet of technocentric approaches, which is there's a heavy emphasis on malleability of code, the universality of code. Code is code and devices are often positioned as tools for emancipation. It's a term I'm quoting from the literature. Lots of people who've used such phrases, so not finger pointing here. By the way, I'm also implicated in all of this, right? So I'm also at the center of my own critique, and I want to be very upfront about it. And when we do that, we engage in something that I'm going to call symbolic power. I'm going to borrow Pierre Bourdieu, the French sociologist and scholar's work here, and we'll get into that later on. And when we do all of this, it has implications for our own methodologies as researchers. We end up in a recursive loop that's not helpful. Very fun computing professor once told me that, Pratim, it's very easy. Recursion is very easy. Anyone can start it, but only some can stop it, right? And so I want to kind of stop this particular form of recursion. I want to encourage us to think how we can resist this, where when we say we are measuring or observing or measuring experience of computing, what we're doing is we are observing those experiences once they're folded back onto code and devices. It's partly unavoidable, but what can we do to actually think about other possibilities? And when we do this, and when we are not aware of our own shortcomings here, then this leads to a form of symbolic violence, where we misrecognize experiences of, and these are fundamentally moral and affective, so emotional dimensions of experience. We misrecognize them as complicity or docility or a willingness to just go along. So there's a form of muting or omissions of voices that have already been left out from formal education and discipline for centuries, right? So the call is fundamentally a moral call, and I've been a little coy about that in chapter 1, but not quite. I mean, there is you can follow through the moral arc in chapter 1, voice and code, and so. But how do we counter this? And not to create another binary. I mean, heterogeneity cannot be a binary, because part of a binary, although I'm phrasing it as a term in opposition to technocentrism, but what heterogeneity should be a reminder for is that I think a lot of the work in computing education since the 70s has centered notions of ownership and control. And it's a misrepresentation of the complexity that human agency represents. And so we need to push back on notions of individual ownership and control. But at the same time, we need to center voices and dignities of learners and teachers, who are usually positioned as, oh, we go in and we know all as researchers and designers, and we tend to teach teachers. We tend to teach teachers how to teach, and we tend to teach, obviously students are learners, but we need to. So they are already positioned as learners, right? But what happens when we start with them? When we center their voices? How does code change? How does coding change? Right now, and then what happens when we unfold computing, what we count as computing, beyond and away from these devices, without excluding them, though, right? I mean, it's easy to say, okay, if I just get rid of computing, there would be no technocentrism. Another kind of fallacy, but we're not going to get into that. But that's not what the argument is about. The argument is about that these devices are powerful, they are in our lives. So what do we do to keep them, to include them without centering them, right? And all of this, it would be easy to say that, oh, we are arguing for another conceptual shift from computational thinking to computational heterogeneity. Not really. What I'm arguing for is an axiological shift. An axiological shift means a shift in what we value as worth learning, right? And so this is, and the moral and ethical dimensions are kind of pivoting this shift here. Across, I would say since 2004, I used to be a physicist until 2004, and then I shifted to learning sciences. And so some of my physics metaphors might appear, but since 2004, I've been working across a wide variety of contexts, in a wide range of timescales, ranging from a few minutes, so the first 23 minutes of what happens when people interact with code, to 2 weeks, to a year in classrooms, multiple years in classrooms, often with the same teachers and the same students. And then, of course, since 2015, open computational science in public spaces. And so my insights are going to be collected across these settings. And with that, I'm going to jump into the first part of the talk. So coding is heterogeneous language in the classroom. And this is mainly a set of chapters from the book. So the first slide is on chapter 3 in our book, and it's called Coding as Perspectival Work. And this is the work of my ex-student, Dr. Amy Farris, who's now an assistant professor at Penn State. And Amy, we were co-teaching a class together, a summer class together, and as part of the class, and the class was focused on modeling, using code to model different kinds of phenomena in sciences. And at that time, we were working on building a programming language called VMAP. And because this talk is against technocentrism, so I'm not even going to mention anything more about VMAP, but you can look it up if you want. But we were designing VMAP, and these were days, around 2009, 2010. So blocks were just coming into maturity, and we were trying to build a language that allows kids and teachers to work with it right off the bat, and to work with blocks, but also make their own blocks using text-based code. So we were designing for a long-term engagement in the classroom, but in ways that are actually directly tied to curricular mandates. And we were working in Tennessee at that time, Tennessee, USA. So we were working with curricular requirements in that particular state. And so that's the context of this work. And this is during the early phases of that work. So at that time, what we found was that science teachers and math teachers were one and the same from up until grades 4 or 5 in many schools. And so often they would find ways to work with mathematics problems that could also be science problems. So then we started thinking about, okay, what could some problems look like? We started working with teachers and they helped us think about problems. And this was one example where we showed 2 graphs and we wanted students to come up collaboratively in groups of 2 with code that total geometric solutions actually to the graphs that could represent a phenomenon happening in a real world from which both these graphs could be generated. Complex problem, but that is sometimes the nature of work that we do with students. The problems that take a long time to solve, and perhaps they might not even have solutions in some cases, but the engagement with the problem itself is where the learning happens. So what happens here is Arnav and Liam, the 2 protagonists in this case, the first 23 minutes of the conversation was where everything unfolds, where they are just trying to figure out what the heck have these 2 folks given us. What is this? How does this even make sense? So they're trying to, each person is bringing in their own points of view. And this became a very technical term for us in this chapter. So we found that each person was engaging with code and the problem, but enmeshed in a few different perspectives. These are visual spatial perspectives, temporal perspectives, perspectives of looking at the graph and trying to describe how the graph is looking, the shape of the graph, then zooming out, taking on the perspective of an object in the real world, then thinking about the turtle on the screen. But each of these result in different utterances that are meaningful to each other in different ways. And then at the end of 23 minutes, we found there is a resonance that happens where they're able to figure out by various forms of trimming how these 3 perspectives can cohere. And it's at that moment of coherence they have enough clarity to say that, okay, now we know what to model. But just in that process of trying to align with each other's perspectives, they have figured out the problem. They have figured out half the code that they need to write. Here is an example like this, and a lot of this work. Here's an example of work that actually happens outside the computer, with the computer, but so much of it is discourse, so much of it is just pointing things, so much of it is embodied interactions, right? And we also found that key points of perspectival shifts were prompted by teachers. And we actually saw this over and over again in classrooms where teachers might not know technical terms that educational researchers do or learning scientists do, but they know implicitly what perspectives are. And perhaps an ineffable quality of teaching is being able to shift and recognize and shift modes as needed, right? And once again, so this is not a glorification of, look, what a great activity design this is, or what a great tool this is. This is really about everything else that happens and needs to happen in order for the activity to become meaningful. Second, I'm going to highlight chapter 4 from Voice and Code, which is Addressivity in computational design. Addressivity is a term that I use from Bakhtin, and it simply means that an utterance is not just like a word that gets thrown in the ether, in the social ether. An utterance is always directed towards someone else. So words are looking, it's almost like if you have to ascribe intentionality to language, it's that language seeks another. Once spoken, it seeks a listener. There's always an implicit listener. And design is language animated, where the speaker and the listener are put in contact with each other. Right, and so here what's happening is we had a year-long unit designed in partnership with a fourth grade class teacher, and we found that the teacher and the students actually wanted to work on one problem from the beginning. And the problem was they wanted to design a mathematical machine, a machine that generates mathematical shapes, that's partly controlled by hardware, partly controlled by code. And the setup that they were working on was two distance sensors linked to VMAP, and VMAP code would control how input from the sensors would get translated into turtle shapes. Turtle movements and turns, right? And so you could basically think of, if this is one sensor, your hand in front of one sensor, this is your hand in front of another sensor, you could be doing this, and you could be generating, by some magical combination of the code, you could be generating a square or a triangle or a circle, right? And the simplicity of this action actually is so misleading, because building these machines, testing them, and iteratively redesigning them and redesigning the user guides took one entire year in a school year. And this is, and chapter 4 walks us through the different parts of that year. And the key realization that we had was it mattered when we brought users in. And this is not to say that user-centered design is the solution. It can still, a lot of studies that actually bring in user-centered design are still focusing on, user-centered design as a pedagogy can be effective in teaching coding. That's not the story. That's maybe the first line, the superficial answer of the story. The layers was the experience of being with the user was a fundamentally transformational one. So once users were brought in, students were shocked. I remember a fourth grader just, once the users left after the testing, and the users were real people, real math teacher from other schools coming in and figuring out that, and the students figured out, oh my God, our instructions just don't work. All the stuff that we thought, the user guides that we fancifully designed, none of it works. And so, fourth grader grabs me as the users were leaving and says, it's not our fault. It's basically the point he wanted to make is that it's not my fault, it's theirs. And this is, by the way, at the same time, I must say that programmers in my lab would often say similar things when I would take bugs to them, like, hey, and they would say, no, it's a user problem, right? And so this, and there is something fundamental about feeling ownership of artifacts and code that we design. And this is where the pivoting happens. This is where teaching became important. So the teacher decided to amplify these moments of dissonance between use and design. And then for the whole month after the first user testing, different people in the classroom started playing the roles of users. The teacher became a user, I became a user, and students started respecting that difference. And in the second round of user testing, we brought back the same users. And what we noticed was that students didn't want to control the device. They they were okay with difference. They were using different forms of explanations. The middle photo there, when in the first user testing, when users would ask them what's going on, they would actually just do it for the users or show the users. And the second user testing, they would offer animated explanations. This could be gestures, this could be body movements, this could be pointing to the screen in mathematically meaningful ways. Also, their user guides became a lot clearer mathematical explanation. Each of the user guides had a mathematically oriented goal, right? And so this is not about personal meaningfulness. It's about becoming meaningful to someone else who they know. This is not an abstract user. This is not following principles of user testing, user-centered design. This is not the superficial fallacy of, oh, as soon as I create a product, and this is rife in constructionism, by the way, that the very act of creating a product itself is a public artifact. Not really. Publicness is a much more complex experience, and we're going to peel off the layers through the top. Then the other work I wanted to highlight here is perhaps the longest study I have done, and perhaps one of the longest studies in the literature, over 2 years. And this is again work with Dr. Amanda Dickus, who's now a scientist at the Gulf of Maine Research Institute in the US, and Amy Ferris also, so Amanda worked with the teacher and her classroom. In third grade, Amy worked with the same teacher and the same class, almost the same class in fourth grade. And what we found was in year one, the teacher was really the focus was to find a sweet spot between coding and science and math. And so it turns out a lot of the turtle geometry activities were already things that were intuitive to the teacher, and they were doing it anyway with their bodies, with paper bar graphs, and so there was a lot of mapping that happened. But we did do another interesting analysis of the amount of time that the teacher would spend on the computer and outside the computer trying to teach what would still be called computational modeling or coding. 35% was on the computer, 65% was outside the computer, where the teacher would unfold and animate these activities. And two examples are given: the embodied animation of a circle that the teacher is mapping, and you will see a student behind the teacher who's basically going to follow along, and then what unfolds is a class-wide discussion of what happened. So describing concrete observations, describing embodied actions was what was needed to make code meaningful. Another form is unfolding shapes as graphs, and so you could basically unfold each side of a square and line them up one on top of each other, and then you would get a perimeter graph. So very, very smart mathematical devices that the teacher was designing, right? And then we saw something else, and this is a truly brilliant observation by Amanda, that the teacher actually, throughout the year, the teacher gravitates toward what Paul Cobb would call socio-mathematical norms. So socially and mathematically grounded norms for creating mathematical explanations. And what this means is that there might be initially a lot of diverse ways to express measures, and the teacher would streamline those measures through class discussion and setting up normative expectations so that things that the teacher thought were very important, two things that the teacher, in this case, Emma, thought were important. One was prediction and accuracy. And these are her terms, not canonical terms. And I want to be honoring of those terms. So in order for the models to be predictive and the models to be accurate, she wanted to bring students together in a set of normative expectations for creating their models as warrants. For models would then have warrants, which would be either in the form of data that they collected or embodied actions that they have done, right? And then in year two, what happens is the teachers start reflecting on, okay, there are instances where they still start out with this notion of making measures concrete. So drawing a shape, what does it take to design a robot to draw the same shape that we're drawing on the computer? Okay, then can we measure? And the teacher had established accuracy and prediction as important in year one. They carry forward those notions, but then now they want to test out some of these ideas using designs for robots that the robots are going to enact in the real world. And when they start measuring when they start measuring movements of the robot, they figure out that there's a lot of error in measurement. And once the teachers recognize, once the teacher recognizes that actually talking about error is a very productive way to actually engage in engage in talking about code and science, then the game changes. Then the game became that, okay, she went in, she amplifies a moment in that measure, designs another activity, a different activity, balls rolling down a ramp, then leading class conversations about the different ways in which you could measure and the different kinds of error that you could have. And all of a sudden, a few months into year 2, the conversation is now shifted away from homogeneity to heterogeneity, to valuing different forms of measure, valuing uncertainty, and so on and so forth. Right. And so the implications for pedagogy, I'm going to move on to part 2. The implications for pedagogy here is that code is utterances and intertext. So code lives in translation across these different forms of activities in the classroom. Code is not just in the activities, but is also what is being transformed and translated back and forth into different forms of representational systems. And teacher voice, if we center teacher voice, then a lot of new phenomena will happen. A new phenomena could be in education, could be a new activity, could be new linguistic. And chapter 7, I think chapter 6, right? Chapter 6 in Voice and Code talks about linguistic references that the teacher invents, open shapes, closed shapes, accuracy, prediction. These are their inventions, their sort of meta coding language, meta modeling language that they're inventing, right? And if you listen, if we have the humility as researchers to listen, then I think we will be pleasantly surprised, literally beyond our imaginations. And then uncertainty and ambiguity play central roles in long-term deep engagement. This is true in professional science. This is just as true in K-12 science. The work of Rich Lehrer and Leona Schabel are profoundly important for any scholar who wants to engage in this work. Doesn't matter if it's data science or computing ed. I think the work of Lehrer and Schabel is fundamental, and they offer fundamental insights into how uncertainty and ambiguity could actually be leveraged in modeling. But this recognition takes time. We can't go into a classroom and just assume that, oh yeah, this is, if I just tell the teacher, if I just tell the student, they will immediately learn. Okay, part 2. How am I doing for time, Diana? Sorry.
You've probably got about 5-10 minutes left.
Okay, all right. So the second part is a more a heavy part, and this is where I'm going to talk about symbolic violence. Symbolic violence is basically, I borrow this from the work of Pierre Bourdieu and Michael Borovoy, and it's the power of constituting utterances. Who gets to decide the form of language, the form of the set of expectations, and then what happens once those expectations are sort of normalized? Some other people who are not included in that decision making, or whose voices were ignored in that decision making, their voices get sort of what feels like their consent, maybe simply reifying a historic oppression. Right, and this is a set of studies that we've done on ethnocentrism, and this work is still ongoing. And the crux of the argument I'm going to make here is that there's a long history of this work going back to Thomas Schelling, who won the Nobel Prize for modeling racial segregation as an economist, Bob Axelrod, who uses this model, and Schelling's algorithm designs ethnocentrism simulation. It's now well used in many different social sciences literature, and you can find NetLogo models of it that are wonderful. And the crux of this algorithm is that it's based on information asymmetry, trade-offs, where it's almost like people are deciding based on trade-offs, right? And but so we took this simulation as in two settings. One, in a predominantly white classroom in the South, and where it worked like a charm. And we found, and this is chapter 5 in Voice and Code, we found that the culture in the southern US is that slavery is not talked about. And so we were able to actually get a class of predominantly white pre-service teachers to engage in critical conversations about race and slavery. as they engaged with the simulation and a racial dot map of segregation in the US. And the insight there was, what we call something, we term transitional othering. Pappert's transitional objects became a transitional other. It became a space for both the self and the other, but without necessarily implicating the students. And so there was a bit of safety there that was created, right? But all is not hunky-dory here. And chapter 5, by the way, shows that this happens through progressive recontextualization. Neutral algorithm, neutral code, transparent language becomes progressively recontextualized in a safe way. But the misrecognitions were also there, and this is our paper that came out earlier this year in Qualitative Studies in Education, where we actually, when we dug deep into the discourse, we found that they were using language that would trivialize or ignore or misrecognition of so plantation owners would be and forcibly enslaved people would be treated as forcibly enslaved people would be treated as cosmopolitan, right? And this is not their choice of term. This is what the algorithm dictates. And then we started, as we started working with more people of color. This is Apurva Chokshi and Bashak Helvichi-Ozagar's work, also reported in the paper. And I will share links to the paper after my talk, right? So, and what we found was it does matter a great deal that the code was written as entrapped in a white gaze. So how migration is represented or how reproduction is represented in the code. And that is determined partly by the nature of the programming language and the paradigm that is being used, but also by the choice of the algorithm, how notions of information and trade-offs are implemented, right? And so maybe those things need to change. And then Simran Trehin and Megha Sanyal, PhD students in the lab now are really advancing that work and taking that work forward. Simran is a scholar of reading and literacy, and she is focusing on how reading code can challenge the white gaze and what does it mean to read code as a form of engaging with code critically, right? And centering moral dimensions. Megha is investigating how technology, migration, and affect and literacy have historically been fundamentally intertwined. So perhaps what we're calling computational literacies itself might need to change. Shantanu Datta is actually working with me and Ariel Ducey, my colleague in sociology, and Martina and Kelly in medicine to actually highlight ethical historical dimensions of that are often ignored or omitted in studies of technoscientific discipline in practice, and really highlighting that on one hand there is the technocentric view of here is an algorithm or a device that fixes people, and here is the actual experiences that unfold when we center marginalized voices and histories. And I'm going to end here. I'm not going to go into the public part of the talk, but I'll give you a glimpse of some of the possibilities that the foundations of discipline, and it's not just computing, most disciplines are, as we know it in the Western Academy, which is now replicated world over, may be entrapped in the white gaze and white innocence. This is a hard thing to grapple with, but we must grapple with it. It's beyond time. Analogical mappings between code and lived experiences may be fundamentally oppressive from the perspective of marginalized people. A lot of work is coming out now. Safiya Noble's work is a great example. Ruha Benjamin's work is a great example. Morgan Ames, again, if you haven't read Morgan's work on what happened actually in the OLPC implementations, please read it. And then universalizing goals of computing and computing ed may be at odds with learning, both what is being learned and who is learning. And this is not an argument for personalized or differentiated instruction. That would be trivializing the point. Rather, it's an argument for making fundamental changes to code and algorithm. I know I'm out of time, but I'm going to show, I know the public computing work has a wide interest. So I'm going to show what happens when we step back as designers and let code be what Marie-Claire Shanahan and I have called a public sidewalk. So this is Canada Day celebration, and what you're seeing here is an installation of the flocking algorithm designed by a lot of folks in my lab at that time. And what we changed the code to do was you could record any sound or song onto a computational object that Craig Reynolds called a Boyd, and he originally made the flocking algorithm. So a Boyd could carry your song or your verses, and then it would play a silent disco. It would play the song silently to its own ears, and then it would react based on the frequencies of that song. It would move, so you could see, and on that day, 14,000 visitors were in the National Music Center, and so a fair amount of them actually interacted with the code. And so we had sounds of the city, sounds of people in the city being carried by different flockmates, and the flocks were emerging based on each individual Boyd's song that were recorded by people. And I could again end here by saying, look, I'm such a great designer. I thought of all these things. I designed all these things. But the video that I'm going to show you is actually going to make my point, and I'll let it speak for itself. And that's it. I have one more slide, but I think I'm going to end here. So yeah, utterances, not artifacts, centering stories from the margins, intergenerational interactions, challenging symbolic violence, making visible moral undertones. This is what we can get to if we do not center devices and code. But I want to point out that devices and code were critical in making these interactions explicit, right? So this is not a call to abandon, not a call for being a Luddite. This is a call for being morally aware of our actions as computing education researchers. And thank you for being with me. This is your prize at the end. I'm a cyclist and an active mobility advocate, and this is literally the most beautiful place I've biked in. It's the bike path that connects Canmore to Banff. And this is, thank you for bearing with me.
That's brilliant. Thank you very much. And we usually do wave hands or put thumbs up at digital ones or physical ones. And there's been lots of interaction in the chat, people very really aligning with some of the things that you're raising. So I think we're going to have great discussions. So Pratim has suggested some discussion prompts for the rooms, and I'll read them out because then you can start thinking about them. But of course, have your own discussions, and Diana can also sort of somehow pipe them into the individual rooms. How can computing education change so that human dignity and moral dimensions of human experience are foregrounded? That was the first one. How can we work to center teachers? This is something very close to my heart, in research practice partnerships. And how can we move away from technocentrism without abandoning code and computational devices? Well, welcome back, everybody. And I hope you had great discussions. And I'd like to invite you to ask your questions. I can see that Julie already I think has a question from Ethel's group.
One of them was about the use of language and the use of language within coding. And I automatically thought, when the slide came up, about class and the fact that we just take that word for granted in object-oriented programming. But when you think about its antecedents, it's being class, upper class, middle class, lower class. and the baggage that goes with that, and that words change, they develop over time. Some of that baggage gets lost, and so you just see the word for itself.
Right.
We came from that to an understanding of that word as being used within a context, but it's the intention that somebody has in using that word that matters. We also chatted about that use of language and the experience, sort of joining the language and the experience together. But it's the language that's focused upon rather than the actual experiential thing. So that when we're coding, we're engaging in anything to do with technology within the classroom or wherever, we've got to think really about the focus on the experience and using language rather than having language taking over. We did talk about other things, but if there's anything else that comes up, I will put my hand up.
I don't know whether you want to respond to Julie's comment.
I do actually. So this notion of, and again, first of all, I think those are great observations and very resonant with our recent paper. I shared a downloadable link to that paper in the chat just now, the language and symbolic violence paper. And I didn't assign it as a suggested reading because it's heavy and it's written for researchers in the learning sciences who work in computing. So they have a higher tolerance for jargonized theory than, let's say, in other fields in education. But it was necessary, and what we do is we take on these critiques head on, like objects, classes, inheritance. If we use, we are kind of, those are the containers, those are the schemas in which our algorithms and our representations will be conveyed. So then how does it entrap us? And we center actually, but to understand this entrapment, and this is where I think this is the social horizon, to use Bakhtin's work. This is the social horizon of language that we must bring in here. If we want to understand its drawbacks, then we can't start that analysis from being entrenched, from the point of view of being entrenched in the code. We need to bring in other worlds that are not about the code, but about lived experiences. And so we brought in the scholarship of a famous, by famous, I mean a wonderful Dalit scholar, Gopal Guru in India. And he talks about migration in Dalit communities and how that was tied to a moral resistance. And we contrast that image with how migration is represented in ethnocentrism. And now the argument there would be that, look, I mean, this is a universal schema, not designed with Dalit communities in mind. And that exactly is the point that we make, that if you haven't designed something for everybody, let's not pretend that it is universal. It is not. Simulations of ethnocentrism are used quite effectively in market research. But it's different to say that I can model consumer behavior, and maybe by modeling consumer behavior, I'm also orienting consumer behavior toward ethnocentrism. And that's a different critique. But to say that this simulation can stand in for a much more complex set of social phenomena, that's where we become technocentric. And so then the solution is still to be decided. Okay, I mean, do we get rid of code completely? Perhaps the experiences of Dalit communities in India cannot be represented in Schelling's algorithm. It's not a model of trade-off. Forced enslavement cannot be represented using, there is nothing that when people are forcibly enslaved, they're not trading off anything. They don't have any freedom. And that I think is it's such a fundamental experience of misrecognition, as Bourdieu would call it, that just because I'm being helped by someone, and this problem is rife in India to this day, right? And in many other countries, in many communities, how we treat the help, I think, is a great example of us unleashing this oppression every single day in our micro interactions. And then we say that, oh, but we're paying them, so it's trade-off, right? It's asymmetric a little bit, but it's still a trade-off. They're here. They show up the next day, right? As if they have a choice, right? And that is where the critique needs to happen. So can we see these shortcomings? And we won't be able to see these shortcomings if the conversation ends up being that, oh, but look, now my fifth grader understands Schelling's algorithm. That might be making the problem worse, right? And that's the other piece of the puzzle. So we need I think what we need, and this is what I meant by changing discipline from the inside, what I would like to see is computer scientists engaging with society. And I have a paper with Thomas Phillip. I'm also going to share a copy of it that is downloadable here. I'll link to the copy and share copy link, theories of learning as theories of society. And it's published last year in Journal of the Learning Sciences, and this is and it takes on this notion of disciplinary authenticity in computing education head-on. It centers scholarship by Pallavi Banerjee, a sociologist, and also happens to be my partner in real life, but really it's her work as a sociologist that I got changed by, and she studied for a long period of time how families of programmers and IT professionals were affected by immigration policies and employment policies that were designed to oppress families in very specific ways, the workplace segregation that happens. Now, if we center these perspectives, then the entire facade of what counts as authentic computing practices crumbles. It rests on oppressive labor. It rests, but not just anyone's labor, labor of people of color who migrate from the quote unquote other worlds, right? And so what does that mean for computing? And these are not going to be easy answers. These are not going to be easy problems, but they must be asked, and we need to be changed. We need to be changed in this moment by these conversations. Not because I'm saying it, but because most of the world are affected by the discourse that happens in ivory towers. This eventually, I'm remembering the work of pragmatist philosophers who argued that the great function of great universities is to perpetuate bureaucracy, right? And perhaps that's all that we're doing, right? All of this great chatter about computing education, critical computing education, if this ends up not changing the problem, if this ends up just saying that, oh, now I have a different way to understand classes and inheritance, maybe something is off here. And so we need to be ready for big shifts, but at the same time, we shouldn't be scared of it. This is exciting stuff. I think we are at the brink of perhaps many new paradigms of computing.
That's brilliant. What a full response to that. That's great. And I see Miranda's put a link in about different, more inclusive words, the ACM. Thank you, Miranda. So that everybody can have, who wants to say something. So Jane, you've put lots of questions in. Could you just ask one? And then we've got Catherine, and then we've got Frank.
Hello, thank you so much for your talk. It's really interesting, Pratim. Really interesting. We talked about a range of different ideas, and I'm going to ask you the question on we wondered about your ideas of the friction in big companies, and so like big companies wanting more technocentric students coming through, and so even if we do things in K-12, how do we kind of interrupt or disrupt the status quo that's in industry?
So I must own up to my privilege here. I am a lifelong academic. I was born in an academic family. I mean, political sort of mix of politicians and academics. And if you ask me in grade 1 or grade 4, I would have given you the exact same answer as I give you now. I'll be a professor. I have not lived a day outside the academy. Please, I wanted to own up to that first. A lot of my students are in the industry. They're very successful in computing, in computer science, and big companies who are often termed evil. I begin my answer by saying that because I think it is. It's easy to say corporations are evil. It lets us off the hook. And I don't want us to do that. Corporations exist, and we are implicated in that too. And at this point, I don't think there is a way to say that we are not going to engage with technology or social media or the cloud. So I think it's redefining and reorienting terms of engagement. I think a lot of the scholarship the Algorithmic Justice League is doing, I think, is an activism. So I think centering activism as part of computing education scholarship would be a wonderful thing, would be a wonderful way to move forward. I also believe that if you listen to teachers, and this is where I think I was transformed when I started hanging out in classrooms as a graduate student in education, that was perhaps the most profound life-changing experience for me. When I saw, and I was working with the same homeroom teacher 3 or 4 days a week, teaching with her, learning with her. And did that for a number of years, 4 or 5 years, and before I became a professor. And what I found was teachers often have to face fund crunches. So the mandate might be to teach coding, but there might not be enough funds for the teacher to bring in new devices or new computers. And yet, the moral arc of teaching is so strong that they will figure out activities that do not use these devices, right? And they still get somewhere. And I think it reminded me of the versatility of motherhood. And I saw my own mom make things from nothing. Feed a family from nothing, feed guests from nothing. And I have a very, very profoundly moral, I had a very moral recognition of the work that was happening. So it was never about devices for teachers who I've worked with. And I think if we listen more to teachers in computing education, we are going to be able to center activities that will go deep. Teachers always want to engage with researchers in ways that also center them. So through collaborations, we can go deeper into that invariant core of discipline, but without necessarily centering devices that corporations are going to push on us. And I think teachers will have a critical role to play in that fight against corporations wanting to take over. Okay, so companies might have investments that they want to see payoffs on, so they might be pushing devices. But I believe actually very strongly in teachers. A colleague of mine actually works on, all my pushback against assessments becoming technocentric, progressively and recursively more technocentric. And a colleague who works on assessment pulled me aside and told me that, hey, if teachers don't work on designing assessments, guess who will design for them? Corporations. Right. So there is something, again, I think I'm going to center teachers. In informal spaces, as my student and now colleague Stephanie Laddick has, she's working at as a postdoc at the University of Colorado at Boulder. Stephanie's work showed that we had this fantastic installation, or so we thought, at the Science Center, and then we thought, and what we found was the actual work was being done by facilitators. Right, so and they were engaging for hours sometimes for hours with the same visitors, sometimes for minutes, like 5 minutes to 10 minutes to an hour and a half, all these various time scales of engagement. And these facilitators didn't know necessarily how to code, but they knew how to facilitate. And there is a lot of scholarship there. There's a lot of value that they're bringing in, right? So I don't know, that's a long answer, but people and teachers before devices. At all costs, at all times.
Thank you.
Thank you. That's brilliant. Now, I think Catherine's question, she says, is quite similar. So in the interest of time, let's go to Frank. We think has got something different.
I have a remark to Pratim.
Yes.
I am a scientist now. I'm a physicist. I'm coming from a non-academic family. My father was a builder, and my mother a secretary. And in my eyes, these 5% of all persons on this planet that are capable to learn a programming language, that's not coming from me, that's coming from a professor of a nearby university here, is able to learn that stuff. It's saying that an algorithm may possibly harm what you said about the shelling algorithm. If a teacher can't tell that the algorithm that somebody created a model, then I think the teacher is doing a bad stuff. In my eyes, education is the only chance by technology to solve the problems we have on our Earth. We are now about 7.7. In England, it's called billion people on this planet, and in every 30 years we are doubling, and you can calculate the next 20 or 40 years, then we will be in trouble again. And I think we as a Raspberry Pi Foundation, or people interested in the complete stuff, have a wheel we can drill on, because the computer, I'm working with Raspberry Pi 400. It's a very good model. It's very cheap. I think you can get one for 17 euros in the meanwhile. And that's a platform you can teach the world programming, informatics, and on that, what I told in our group before, you can teach them how the work is working. For example, the corona problem, that's not a good idea that everybody gets out and is doing a party. I posted a link before about the Khan Academy. That's an online resource on YouTube where you can see really mathematically explained what things are good, what things are bad. In the sense of dying people, for example. And if there are other scientists, this is my real opinion, if scientists contribute to models like that are translatable to computers, to short programs, then that's not a bad thing. Technocracy, there are problems, we have problems on this planet, but the word class, what you said is what I heard in the last minutes, that the word class might be a problem. Every pupil is in a classroom learning. So I don't understand why the word class is a problem for young pupil to use sorry, didn't got that. Perhaps Pratim can reply on that.
So yeah, I mean, first I would recommend Morgan Ames's book, The Charisma Machine, also Lily Irani's work, Chasing Innovation. And both these books are, I think, books that we should be changed by. And both these books challenge the notion of solutionism, that technology and innovation can solve the world's problems. And I think there is a lot to learn from that perspective. They can help. I mean, everything that we do, everything that humans do can potentially help others. And in that sense, perhaps technology, if you think of that as human endeavor, can help. But the idea of, so I think that needs a bit more thinking, and I'm going to invite all of us here to be changed by the books rather than engaging in discourse about it right now. So Morgan Ames, Lily Rani would be great scholars to think with on this bigger vision arc of why technology, that question, right? And why innovation. And also the term innovation, if you're being a bit pedantic, if I may be a bit pedantic here, it actually means renewal, to renew, rather than to displace or disrupt. And those are relatively new meanings. And I think there's something for us to think about there also. And also we should think more critically about the history of failure. And I'll send a link to Sue. I'm not being able to remember the name of the scholar, a wonderful American historian at Carnegie Mellon, wrote this wonderful history of failure and innovation, which is a lot more nuanced than the celebration of, oh yeah, failing is great, and how this was tied to people's dignities and credit histories and trading before in sort of the near industrial right after industrial eras, right? So I think there's a historical arc to all these things that we are thinking about, and we need to ground ourselves a bit more in history. To your second point, the notion of classes and inheritance being problems, they're not universally problematic. They can be problematic when we take models to represent something that they're not designed to represent. And essentially this kind of thinking is fundamental to modeling, to learning to model, modeling literacy, modeling as a scientific literacy, modeling as a computational literacy, when to use what kinds of abstraction, right? And I think it's very fundamental to that. Sue, yeah.
Yeah, I'm sorry to interrupt you in flow, but I'm conscious of the time, and because we're coming to we need to finish at 1:30 the hour, and people might have meetings to go to. But that's a fascinating discussion, and thank you for giving such full answers. That's so I just need to wrap up, and we just want to say thank you again to whichever hand waving way you want to do that, or in the chat, to Pratim for a really thought-provoking talk. And thank you also for everyone who's put things in the chat, the links. We will save the links and share them with you. We have a survey, so we always want to know how you find our seminars, and we're really interested in your feedback, which you can give us through the survey. We also have some more seminars coming up. Next month we have Yasmin Kafai from the University of Pennsylvania coming to talk about electronic textiles. And you can see the other speakers. We have a break always for August because Diana and I like to go on holiday. And then we've got September, October, and November. We have the speakers you will see on the slide there. I'm rushing through, conscious of finishing off on time. But thank you so much to everybody for coming along. We really, it's a group effort. Thank you to Pratim for presenting, but thank you to everybody else for engaging and joining in the breakout rooms and asking questions, and it's just really special. So thank you very much.